All right, boys and girls, this is lesson 3-4. We're talking about real numbers. So this is the rational numbers, integers kind of talk. So right now I need to make sure you get down the essential question, and then you're going to want to make this Venn diagram because rational numbers, there's a definition here, they are numbers that can be written as fractions. So no matter what, every single number in this Venn diagram can be written as a fraction. What I'd like you guys to all understand is that rational numbers, the big circle, includes integers and it also includes all whole numbers. Now, whole numbers are just the positive numbers, 1 through whatever. Integers are all of the whole numbers and their opposites. So I cannot have an integer be a negative 1.1. That is not an integer. That actually falls into a rational number category. So again, all rational numbers are something we can write as a fraction. Integers are the positive and negative whole numbers, and then whole numbers are just all of the positive numbers. Okay, so make sure you have that written down. You'll probably want to reference this later on today. Irrational numbers are any number that you cannot write as a fraction. So they cannot be written as a fraction. They are decimal numbers that do not repeat in a pattern, but they also never terminate. So an example of this, as I'm asking you to do this with a partner, but an example of an irrational number is like the square root of 3. The last couple of days we've been talking about things with perfect squares. The square root of 3 isn't nice. It's like a 1 point something 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 something. Okay? Maybe it's like a 1.7. And it goes on and on and on and on and on and on and on. A nice number would be like the square root of 4, which is 2. The number 2 falls into the whole numbers, falls into the integers, falls into the rational numbers category. So things that are not perfect squares, like the square root of 3, or pi, which goes on forever but does not repeat, are examples of irrational numbers. Okay, so let's go through some examples. Remember, real numbers is any set of rational and irrational numbers put together. And so our first example, we're supposed to name all of the sets of numbers to which 0.090909 belongs. I'll tell you right away, it is a rational number. And that's because it's not whole, which means it's not an integer. And we're going to make sure that we have that it can be written as a fraction because 0.09 is 1 over 11. Okay? Example number 2. Name all the sets that apply to the square root of 25. I try to make that a little bit bigger so you guys can see that's actually a square root symbol. The square root of 25 is 5. It's a positive and a negative 5, so it's an integer. It's a whole number. And it is falling into the category of a rational number as well. So it's important that we have that for ourselves. Now, the square root of 12 isn't very nice, and it's negative, so this is just an irrational number. So that's important for us to be able to distinguish the difference between them. If it was a nice square root, kind of like the 25 was, we'd be able to do more with it. Moving on. Example 4, they're asking us to estimate two numbers on a number line. So I'm going to use my calculator to help myself out. I'm going to have the square root of 8. The square root of 8 is 2.8. And I'm just rounding that to the nearest tenth. And the square root of negative 2 is 1.4. A negative 1.4. So if I were to put this on a number line, here's 0, here's 1, here's 2, here's negative 1, negative 2, negative 3. The square root of 8 is 2.8. I should have a 3 over here too. Is going to be right here, closer to the 3, but in between 2 and 3. So the square root of 8 falls in that category. A negative square root of 2 is a negative 1.4, almost halfway over here, so a negative square root of 2. So it's important that we can use our calculators if you guys need assistance with that. Remember, we showed you yesterday how to do those things. On example 5A, we're just trying to use our less than, greater than, or equal to signs to make the sentence true. We're just going to, again, very quickly, this would be 3.875, because I've taken in 7 divided by 8 is 0.875. And then the square root of 15, use the calculator. It's going to be pretty close to 4, right? So it's going to be 3 point something, so I better check myself here. 15, I get 3.8729. So 3 7/8 is just bigger based off of our thousandths place value. Now, same thing's going to happen over here. We're going to have to check our calculators. 10.4. The square root of 10.4 is 3.2249, which means that this, the square root of 10.4, is larger than 3.222 repeating. Alright, same type of process here, folks. The time in seconds that it takes an object to fall d feet is 0.25 times the square root of d. How many seconds would it take for a baseball that is hit 250 feet straight up in the air to fall from its highest point to the ground? Now, without overthinking this, we're just going to take science into effect that this is like a vacuum kind of a thing where it's just gravity is bringing it down. The wind's not blowing it up. There's nobody using special effects to make things float. So we're just going to plug this number in for d. So 0.25 times the square root of 250. So into my calculator, I'm going to type in the square root of 250, which is 15.811333, and I'm going to leave that in my calculator, and then I'm going to multiply it right away by a 0.25. If I round it to the 15.8 and then multiply by 0.25, it's going to change my number drastically. So I'm going to leave the number that this is in the calculator and then multiply by 0.25. I get a 3.95, and we're talking about seconds. It's going to take 3.95 seconds for it to fall from 250 feet in the air. Alright, folks, that's what we got for today. Make sure you do your homework, and if you have any questions, we'll chat with you tomorrow. Remember, tomorrow we also have a quiz over sections 3.1, 3.2, and 3.4.